So, having explained the variation of potential energy and kinetic energy with respect to time in the cycle of SHM, let us now try to depict these two energy quantities in a graphical manner with respect to the position of the body. Now, I have drawn the position of the body. Now this, instead of time t, I have taken position x in the x-axis. In the y-axis I am going to plot PE and KE. Now recall that KE in terms of time is this, but we can also express this in terms of half Ka square minus x square. We have seen in our earlier derivation. And P is half K x square, which is elastic potential energy, and it is the extension of the spring squared into K divided by 2. So easy to plot PE at x is equal to 0. Here there is no extension, it is at the origin, and therefore potential energy 0. Then I have marked in the x-axis the amplitude of vibration or amplitude of SHM, which is plus A, and this side it is minus A. So at plus A we get half Ka square. So this position corresponds to half Ka square. Now similarly in the minus A, the energy, potential energy is always positive. In the minus A, if you take x is equal to minus A, you get the same value, half Ka square. So this also is half Ka square. This corresponds to minus A. Now what about the kinetic energy? At x is equal to 0, if you put kinetic energy is maximum, half Ka square. So at x is equal to 0, we give here a plot, kinetic energy. The green ink and the green graph is with respect to kinetic energy. So what do we get at position A? That is when the body has reached the right or left extreme, the velocity is 0, so kinetic energy is 0. All the energy of the body is stored in the form of elastic potential energy. So here kinetic energy is 0, here kinetic energy is 0. We get a graph like this. This is our Ke. So at any point of time, you see, Pe plus Ke is always equal to this limit. What is this? This is half Ka square, or in other words half m omega square A square if we replace K by m omega square. Now I will put a question that at which position the kinetic energy and potential energy is same. You can get that by equating these equations. For example, suppose at a distance x both the energies are same, then you get half K A square minus x square is equal to half K x square. Half cancel, K cancel, you get 2x square is equal to A square, or x is equal to A by root 2, which means around 0.7 A. So this point is 0.7 A, 70% of the amplitude almost. So you find here that at 70% of the maximum displacement, we get the potential energy and kinetic energy becoming same. What is the intuitive feeling of it? Look at it here. The whole thing was potential energy at the right extreme, and then it gradually comes up. It gains velocity, and at 30% of the distance from here, or 70% of the distance from here, you find that both of them becoming equal. What in the middle, in the very middle, it is not. You may think that if the potential energy is 0 here and potential energy is maximum at amplitude A, and kinetic energy is 0 at amplitude A, and potential energy and kinetic energy maximum at 0, it may happen midway, that both of them are equal. Both of them are not equal on the midway, that is at A by 2. The reason behind that is there is a square relationship between these two quantities. E and K are in a double exponential relation to that of displacement.